Okay, so this question here wants me to simplify the following. Okay, so if I look at B, okay, I have 5 and 2/5, okay, plus 1 and 5/6. Okay, now whenever I do anything in maths, okay, and I have mixed fractions like I do here, okay, so these are mixed fractions, okay, I don't like mixed fractions. Okay, never try to work through problems with mixed fractions. You need to convert them to improper fractions first. Okay, so let's have a look at how I convert these to improper fractions first. Okay, and we've learned how to do this before. So basically this fraction here, I'm going to put it all over 5 as an improper fraction. Okay, and so to be able to do that, I go 5 times 5 is 25, plus 2 is 27 over 5. Okay, I then add on this one here, I'm going to put over 6. Okay, and so I have 1 times 6 is 6 plus 5 is 11. Okay, and so I've now converted them to, okay, what we call improper fractions. Okay, so that way I can then now look at finding a common denominator and using my normal fraction rules. Okay, so in doing this, I need a lowest common denominator of this. So let's look at, I've got 6, 12, 18, 24, 30. Okay, so 30 is divisible by 6 and by 5, and it's the lowest number that I can find that is divisible by both of those. So my lowest common denominator, okay, is 30. So I want that over 30, and I want that over 30. I then think, okay, to go from here to here, I've multiplied by 6. To go from here to here, I also multiply by 6. And multiplying that by 6 is 162. Okay, and so then what I also need to do is think then to go from here to here, I multiply by 5. To go from here to here, I multiply by 5. So 5 11s is 55. Okay. What I then do is, now that I've got it over a common denominator, I add my top row. Okay, so if I add this together, I get that it's 217 over 30. I then need to look at trying to simplify that, okay, as I can. So 30 goes into 217 7 times. So if I make that equal to 7 and something, so I know that 7 times 30, right, is 210, which means that there'd be 7 left over. So I'd be left with 7 out of 30 at the end there. Okay, and so that's one way of doing this. Okay, let's look at an alternate method that, when we deal with large numbers, this method can work a bit better. Okay, so we have 5 and 2/5 plus 1 and 5/6. Okay, so if we have a look here, the other way is we can think of, well, this is 5 plus 1, so 5 plus 1, where we have our whole numbers, okay, plus 2 on 5 plus 5 on 6. Okay, is a way of looking at this. So I can think of this as being here, 5 plus 1, well, that's 6, and then I look at adding these together, plus I need a common denominator for those, so the common denominator will be 30, right? And so what I simply do is I go, well, I want to write both of these over 30, okay, and in terms of that, I go, well, to go from there to there, I've multiplied by 6, so the top here, I multiply that by 6, and so that gets to 12. Okay, and then also to go from there to there, I've multiplied by 5, so I multiply that by 5, and I get 25. Okay, and so then what I simply do now is that these are over a common denominator. I can simply add the top part, okay, And so I have that it's 6 plus, that will be 37 on 30. And I know that if I simplify that down, that's 6 plus 1 and 7/30. And so if I then think of this as being 6 plus 1 plus 7/30, okay, and then basically it's 7 and 7/30, which gives us the same answer. Okay, so either one of these methods is okay, depending on what you prefer at the moment. Okay, but typically a lot of mathematicians, once we see what we call mixed fractions, we like to usually try to convert them to improper fractions and use improper fractions, okay, in all of our calculations. So the first method is probably one of the better methods.